Hey, thinking about making a 3D top-down action game? Looking for a camera system? In this video I'll show how to make a smooth top-down action camera in Godot, heavily inspired by recent hit Escape from Duckov. To follow the player, it supports Lookahead shift the cursor with a bunch of available configurations. Let's see how it works. Camera in this tutorial has two distinct features. First, it's simple follow the player. It can be with ghosting or immediate mode. In our case, we use a static follow without any delays. Second is look ahead shift towards mouse cursor. It makes these cool aiming and spy ahead features we all love. It has several trigger zones and can be configured to shift less or more depending on game situation, like melee versus sniper rifle aiming. Hi, this is Evgeny and welcome to Jamforge Games, my little YouTube indie game dev channel. So, once you open the project, you need to find and open main scene. This is a demo. The main scene has two components. The environment is just ground and a couple of columns to show the movement better. Second component is our player, inherited from character body 3D as usual. Player has attached camera rig. This is where the magic happens. So the camera rig consists of several Node 3D. Let me show how it works. First, we have a character and we have a fixed camera rig. When the character moves, fixed rig moves along. The second component is shift rig. Shift rig is a moving part of our camera rig setup, and it uses a mouse cursor distance to shift towards the mouse. And then camera attached to this moving rig. If we open the script, first of all we have relative variables to set up all other parts, and we have link to player. We also have a couple of switches, just enable, disable the following target and enable cursor shift. Okay, camera shift works using two radius system. The near radius is when the shift started, and near shift is the power of this movement. The far radius is where shift stopped, and fast shift is basically the maximum power of a shift toward cursor. You can set up them using these variables. We have few internal variables to hold original camera offset, to hold twin instance, and to hold the calculation of lookahead vector. So everything happens in physics process, and it has two phases. The first phase is just to move along the player. It uses a global position plus the static offset of the camera. Phase 2 is very simple. We just apply the previous step position plus lookahead vector. Then we set the global position to this final position. The most interesting part is this calculating lookahead vector itself. The calculating of lookahead vector is happened here in the function addCursorOffset. What this function does is taking the mouse position on a screen, independent if this position before or after fair radius, it calculates the shift value. It also have a little step condition that clamp the lower value and actually lock the maximum value. We also have offset vectors like direction where the shift should happen, and we just calculate this how much shift do we need to do and return these components to save it and look ahead. So once we get this target shift direction and value, we need to save the look ahead vector for next application. For this we actually use the twin component to make sure that we use ease out, a smooth transition toward the cursor. We also have a couple of debug screens that actually draw the near and far radius on the screen. It allows you to visually understand how the mechanic works. So if the cursor closer than near radius, there won't be shift. If the cursor in between two radiuses, it will be linear interpolated value. And if it's further than far radius, it will be the maximum value. So this is pretty much it. The project itself is very simple. The basic movement and rotation also included in the project, so once you get the source code, you pretty much all set up to start building your game or experiment more with the camera. All source code available on GitHub. I also set up link to each IO, and you can just download the zip archive if you don't want to deal with GitHub. Please let me know in the comments if you want a more tutorial like that. This exactly tutorial was more like experimental, and I'm actually planning a slightly different devlog. So please leave your comments and maybe I can adjust the content and also subscribe. Thanks.